Okay, so for lesson 78 for Algebra 2, this is solving quadratic equations. There's a couple of different ways you can do the ones that you're shown on here, like 9x squared minus 25 equals 0. You can see that as the difference of two squares. And then you'd have 5 over 3 equals negative 5 over 3 when you do that. That's a minus. Or you can do what's called isolating the square, isolating that x squared. So that means you'd add 25 to both sides. So you'd have 9x squared equals 25, then divide by 9, and then x is plus or minus 5 over 3. The deal you have to be careful with on this one is always make sure you put your plus or minus because you need two answers, just like you got here. So we've got 121a squared minus 64 equals 0. So it'd be 11a plus 8, 11a minus 8 if you factored it as the difference of two squares. Then it'd be negative 8 over 11 and positive 8 over 11. Or you could isolate the x squared and have 121a squared. Well, here, isolate the a squared. Then divide by 121. And then a squared is 64 over 121, so a is plus or minus 8 over 11. Either way, sometimes they're already set up where the squared term, where the quadratic term is isolated. So you divide by 400. So y squared is 36 over 400. Again, they're both perfect squares, so don't try to figure out that decimal, just leave it, and then take the square root. So it'd be plus or minus 6 over 20, which will reduce to plus or minus 3 over 10. Then another one where they're already isolated for you, 7x squared equals 63. So divide by 7, so x squared equals 9. So x would be plus or minus 3. Again, you've got to remember to put the plus or minus. When you're taking the square root of both sides and solving for x, you've got to make sure you put the plus or minus there. Then if you have something like 10x cubed minus 10x equals 0, take the 10x out. That leaves x squared minus 1. Then you can do a couple of different things right here. You know that's 0, or should know that's 0. And then here you could either factor it as a difference of two squares, x plus 1, x minus 1. So you'd have plus or minus 1. Or you do your inverse operations. It's a minus 1, so you need a plus 1. And you need to take the square root because it's x squared. So it's just the square root of 1, and you need plus or minus. So you can do it either way. You can either do it factored as a different two squares and go from there, or do your inverse operations. It's a minus 1, so put a plus 1. It's x squared, so you need the square root. Plus or minus. Plus or minus, plus or minus, plus or minus. Then something like this. You're going to want to move the x term over to the x cubed and factor it like I just showed you to do on this one. Here, all you can do is take out an x, so that leaves 4x squared minus 49 equals 0. Now, you could go ahead and factor this as a difference of two squares. It'd be 2x minus 7, 2x plus 7, and you can get your numbers from there. Or do inverse operations. It's positive 49 because that's a subtracting 49. You've got to divide by 4 because you're multiplying by 4, and you need to take the square root. So that'd be plus or minus 7 over 2, which is what you get here. 7 over 2, negative 7 over 2, plus or minus 7 over 2. And then don't forget about the x, giving you zeros. Again, you should have 3 zeros because it's x cubed. Just like we got 3 zeros here, it's x cubed. Okay, so you'll see those. You will also see x to the 4th minus 16 equals 0. So here you're going to have to factor this as the difference of two squares. So it'd be x squared minus 4, x squared plus 4. That's the way it would factor, and that's the way you need to factor it. You can't move the 16 over and try to take the 4th root because you're going to get some imaginary roots. So again, you can either put this as a difference of two squares or just do your inverse operations. It's a plus 4, you're squaring, so take the square root, so plus or minus 2 here. Same thing on this one. Inverse operations, it's a plus 4, so you need negative 4, and then you're taking the square root of negative 4, which would be plus or minus 2i. Notice, I have 4 zeros, and it's x to the 4th. And you're going to have those two imaginary zeros. So that's why you just can't isolate and then take the 4th root and say, oh, it's plus or minus 2, because you've got to remember there's some imaginary roots in all of these like this, and all of them that look like this. So if you've got x to the 4th equals 625, you want to move that 625 over first, and then x squared minus 25, x squared plus 25. Then do your inverse operations. It's the subtraction, so you want an addition, or a plus 25. It's squaring, so you want to take the square root, so plus or minus 5 here. Then here it's plus 25, so you want to subtract 25. It's squaring, so you want to take the square root, which would be plus or minus 5i. Again, 4 roots, 2 here and 2 here, and it's x to the 4th. So that's the way you do something like that. And then just know that these are your real roots. So if you're asked for real roots, you just put those. These are your imaginary or complex roots, if it specifies it. Most of these are just saying solve, so you just do both of them. So here, these are real. The one with the I is the imaginary roots. Let's see. Sometimes you might be asked to verify the real roots. It says to use a calculator. Don't use a calculator. Just solve it and just put your real roots. So it's x to the 4th minus 16 equals 0. So that's x squared minus 4, x squared plus 4. I think I already did this one. Didn't I? Yeah, it says to verify it. So what we had a plus or minus 2 and plus or minus 2i. So these are your real roots. And that's all you do. That's how you'd verify it. You just show this work again and just circle the real roots. But don't verify it using a calculator. Just remember that these are your x-intercepts. These are not x-intercepts, okay? These are your x-intercepts right there. Okay, let's see. Then we have 9x squared minus 12x plus 4 minus x squared plus 10x plus 25 equals 0. Okay, so when you have these two trinomials put together like this, that is this is a 9. That's a 9. What's going to happen, the way these are going to factor, is that both of these are perfect square trinomials. That means you can factor them into binomial squares, and that's the only way this can work. So these have to be perfect square trinomials, which means this one would factor into 3x minus 2 all squared minus x plus 5 all squared, okay? Now 3x minus 2. 3x is the square root of 9x squared. 2 is the square root of 4. 3x times 2 is 6x. If I double it, I get 12x. That's why it's a perfect square trinomial, and that's why it factors into 3x minus 2 all squared. That minus sign is why I put a minus sign right there. Same thing here. Square root of x squared is x. Square root of 25 is 5. 5x. Double it, it's 10x. So x squared plus 5 all squared. So now this is the difference of two squares, because these are two squares. So I do 3x minus 2 minus x plus 5, because that's how you factor the difference of two squares, and then 3x minus 2 plus x plus 5. Okay, it's just like if it was x squared minus 4. We do x minus 2, x plus 2. So we take the square roots and then do a plus and a minus. So we take the square roots. 3x minus 2 is the square root of that. X plus 5 is the square root of this one. We add them and we subtract them. So then the subtraction sign goes through. That gives us 2x minus 7 for this set of parentheses. Here, plus doesn't change anything, so 3x and x is 4x plus 3. So this is 4x plus 3. So then we get 7 over 2 and negative 3 over 4. Okay, so let's do another one like that because I know that's weird. Let's see. 25x squared minus 20x plus 4 minus 16x squared plus 8x plus 1 equals 0. So again, they've got to be perfect square trinomials. So this has a square root, it's 5x. This has a square root, it's 2. If I find the product of the two, 10x, and I double it, I get the 20. So it's a perfect square trinomial. So 5x minus 2 all squared is the way it factors because of that minus. Same thing here. This is 4x. This is 1. Product is 4x. Double it, 8x. So it is a perfect square trinomial. So 4x plus 1 all squared. So I factored it as the difference. Now it is the difference of two squares, and now I factor it as a difference of two squares. So 5x minus 2 minus 4x plus 1. And then 5x minus 2 plus 4x plus 1. So I just take the two factors, the 5x minus 2 and the 4x plus 1. I put a subtraction sign between them. I put an addition sign between them. And now I combine like terms. So this would be negative 4x minus 1, which would be x minus 3. And then here 5x and 4x is 9x minus 1. So then now my answer is 3 and 1 over 9. Okay, one more like this, and then I'll show you one more thing, and then we'll be done with this lesson. Let's see, x squared plus 16x plus 64 minus 36x squared minus 12x plus 1 equals 0. Again, perfect square trinomials. This is x, this is 8, 8x. If I double it, it's 16, so it'd be x plus 8 all squared. Minus, this is 6x, this is 1. Product is 6x, double it, it's 12x, so 6x minus 1 all squared, because that's a minus, equals 0. So now it's set up as a difference of two squares, so now we factor it as a difference of two squares, x plus 8 plus 6x minus 1, x plus 8 minus 6x minus 1. So then with the plus, combining like terms, 7x plus 7, because x and 6x is 7x, and 8 minus 1 is 7. And then here that's a negative 6x plus 1, so that's negative 5x plus 9. So then negative 7 over 7 is negative 1 when you finish that. This is negative 9 over negative 5, which would be positive 9 over 5. So watch your signs there. Opposite of 9, you're dividing by negative 5, so that gives you positive 9 over 5. Okay, then one last thing is example 5 in the book on page 554. We have that the height of a free-falling object neglecting air resistance is given by the function h of t equals negative 4.9 t squared plus VOT plus HO. You've seen this before, where HT is the height after a certain amount of time, VO is your initial velocity, and H is your initial height. Then it says, how long does it take for an object to hit the ground? So if I want the object to hit the ground, that means my H of t is 0. Negative 4.9 t squared doesn't change. After it is dropped from a height. So if it's dropped from a height, the initial velocity is 0 if it's dropped. And it's dropped from a height of 40 meters. So it started at 40, so its initial height is 40. So again, if it's dropped, its initial velocity is 0. So what that does for you is it takes out that middle term. So it leaves a negative 4.9 t squared plus 40. Now, a couple of different things we can do from here. I want to show you two different ways to do it. One way is subtract 40, isolate the t squared. Negative 4.9 t squared equals negative 40. Divide by negative 4.9. So t squared is 40 over 4.9. So t, and here you only want a positive answer, so we wouldn't do plus or minus. 40 divided by 4.9, which gives us okay, hold on. Did I not divide? Oh. And then you got to take the square root. Sorry, to find t, you've got to take the square root of the 40 over 4.9, which I didn't write down. So I've got to take the square root, which is what I didn't do. That's why I wasn't getting the... So I'm going to just put it in my calculator as the square root of 40 over 4.9, which gives us about 2.86 seconds. Okay, now another way to do this, if you change all the signs, and if you move your decimal over once, 49t squared minus 400, it's the difference of two squares. So it would be 7t minus 20, 7t plus 20. We only want the positive 20 over 7. Well, 20 over 7 is about 2.86 seconds. We only want the positive because we're looking at time. Time cannot be negative. Remember, time cannot be negative. Okay, so that's that example. And then G is going to work the same. So practice G. You're going to follow this example right here. You're going to follow this example. So let me give you your assignment on this. And remember, you got to copy these notes and send them with your homework. This is lesson 78. You're going to do the warm-up, which is on page 552. You're going to do practice A through G. Then on 78, you are doing 1, 3, 4, 5, 6, 10, 15, 24, 25, 29, and 30. This is due Tuesday. I think that's the 31st. It's due Tuesday the 31st. Yes. So you're doing the warm-up on page 552, practice A through G. 1, 3, 4, 5, 6, 10. That's 10, 15, 24, 25, 29, 30. And it's due Tuesday. Okay.